Ever since I was a kid, I've always enjoyed riding my bicycle around the neighborhood. As I got older, I started to ride around local trails. Yeah, and then I stopped riding around local trails. But I've continued to ride my bicycle to class every day for school. I'm a senior in college now, and it's turned a brutal 20-minute walk into a pretty manageable 5-minute bike ride. And as an engineering student, I'm always trying to solve problems that don't really exist. So as I ride around, I always wonder how far I go each week and how fast I go. So I did some research online and I found several bicycle speedometers. These options were all extremely small footprints. They were either GPS powered or had Hall effect sensors to detect the wheel speed, and they ranged from $20 to $40. All of them offered high IPS waterproof protection, and they all seemed like great options. The only issue was, I want to build one myself. In this video, I'm going to be building a custom bike speedometer using an Arduino, a few sensors, and an LCD display, all designed to track speed and distance while attempting to keep things clean and compact. Moving outside, you can now see my mountain bike. We're going to attach the screen and the whole module itself to the handlebars, and then the sensor to the fork and a magnet on the wheel. Every time the magnet passes the sensor, it's going to count as 1 revolution. Therefore, we can obtain speed from that. But before I could bring the design to life, I had to start from the basics, the components. Let's take a look at some of the main components we'll be using for this project. First up is our microcontroller. This is the brains of the system. It's a USB-C powered Arduino Nano. We'll be pairing that with a 2.2-inch wave-share display that has a resolution of 240 by 320 pixels. This will show speed and other metrics we're recording. And of course, we'll need the data cables and power cables for that. Next is our speed sensor. It's a Hall effect sensor mounted on the bicycle fork that will detect wheel rotations, therefore giving us our speed. For power, we'll be using a USB-C rechargeable 9-volt battery. This is a compact solution that makes the whole unit more portable without needing a bulky power supply. And along with that, we'll need a USB-C to 9-volt to connect directly to the Arduino. To cycle through some of our power modes and screens, we'll need a momentary switch. And last but not least is a toggle switch to interrupt the 9-volt power to turn the system on and off. Alrighty, let's get right into it. So the first thing that we're going to do is desolder our 15x1 headers on the Nano. These headers are used for jumper cables that you would typically find in a normal Arduino starter kit. Yeah, so just kidding. As I'm making this video, I actually fried my Nano. So I picked up some new ones off Amazon. They're off-brand Arduino Nanos, but they all have the 15x1 headers still left on them. And I think just for ease of use and connectivity, I'm going to still use the jumper cables that I have. So disregard what I just said. I'm going to be using the jumper cables and not soldering directly to the board. That way I can move them around eventually and hopefully make it easier. So now sliding on over to the CAD modeling side of this project. This is easily my favorite part of any project that I work on. I love being able to design stuff in SolidWorks, and then having a 3D printer makes it really easy to quickly prototype different parts. So right now I've shown kind of 2 parts that are going to clamp together around the handlebars and hold the screen and the momentary switch. And then the other side of that, which is going to bolt to that front face, is going to be what's going to hold the 9-volt battery, the Arduino, and kind of all the wiring themselves. So now moving into the wiring schematic. For most of the projects that I work on, I try and make a wiring schematic. This really simplifies the overall design in my head. It allows me to visualize where all the wires are going to go and how they're going to interact. As you can see on this project, there are quite a bit of components. It's not the most complicated thing that I've worked on, but there are a lot of wires, and this LCD display on screen only has 4 wires, but in reality the one I'm using has 7 to 8, so it will be a little more complicated than this, but this software didn't have the right LCD display. And it also shows me what common grounds I need to connect. So now we'll move into the 3D printing aspect. I have a Bambu Labs A1 Mini, and I use the Bambu Labs slicer. It's super easy to use, and I'm trying to print the back housing and the 2-piece Arduino housing as well. As I progress through this time lapse, you can kind of see there's more and more stringing as it goes on. Some of that's from the priming tower in the back, but a lot of that's from the poor filament choice, which is PETG. It was kind of some cheap PETG, and there's a lot of thin, pretty substantial overhangs that I designed on that Arduino mount. And so I want to redesign that to allow for higher print quality. That would have instantly snapped. It wouldn't have been good. So in this, I'm trying to make a different style design. So now I'm going to still hold the Arduino upright, but it's going to be mounted directly into it. Alrighty, so here is yet another change that I've made to the design. So this is the CAD file for the rear housing. So the Arduino is proven to be more complicated than I thought to be to mount. And so I designed this this two-piece assembly to actually attach to the rear using a heat press insert. So if I make this not transparent, you can kind of see a little bit better. And the Arduino sits in there upright, just like how it did before, but it gives more room for these pins to be accessed. So hopefully I'll be able to still use those jumper cables and not have to solder. And so yeah, that's what it currently looks like. And so I was gonna show a whole montage of me designing that, but now I've changed it yet again. So this is what it looks like. And so I'll start printing that out. Jumping to the actual printed piece, it looks really solid. There's no overheating that I was struggling with earlier in the year. And the stringing looks really solid. So overall pretty happy with that. You can tell there's only one mounting hole now for the Arduino, and the Arduino will mount laterally like this. So hopefully that frees up some space and allows us to use those jumper cables. Okay, so now that I've got some of the wiring already hooked up, I wanna go ahead and show the UI that's gonna be in this system. So I have the Nano hooked up to the LCD display and then the momentary switch as well to cycle through some of the screens. So what this is gonna look like on the bike itself. So we've got a loading screen here that kind of shows just the name of it. And then this is gonna be the main screen that you'll see. So when the Hall effect sensor is actually connected, this will update live, and then so will the miles for that individual trip. And then as we cycle through some of these screens, you'll see the average speed, the total distance, both will be in miles per hour and then miles. And then the last screen will be, you can't really see it now, but it's gonna be a graph, speed versus time. So, you know, as I progress throughout my trip, you'll be able to see that, this wire's bad. You'll be able to see that kind of move and change. But one of the cooler things that I like about this UI is that if I hold this button down, I can actually cycle through some of the colorways that I can have for each of these displays, which I really like. Let me zoom in here. So this is the magenta one. It's kind of hard to see on the camera, but there's a gray, there's an amber, there's a green. So I really like that feature. And then as I hold it down, it'll stick to all the screens. So far that's what we got. I need to integrate that into the actual housing, but I'm pretty pleased with the user interface so far, and we'll move on to the next section. So first we're gonna look at the assembly itself that's gonna hold the screen and all the internals. So this will have the screen in the front, just like this, along with the momentary switch. And then this is the back side that's gonna hold the battery, the Arduino, and pretty much everything else. So these clip together, just like this. And they're pretty solid, but they're also gonna attach via these columns right here that'll have heat press inserts along with bolts that screw into the face. And so what I wanna do right now is I want to try and see how all this bundle and mess of wires will actually fit into this housing. I'm a little nervous that some of these are gonna pull out. You know, I had initially mentioned I want to solder all these, but I wasn't able to do that. So I want to see how they fit in. So I'm gonna just start putting stuff together here. Yep. All right. Yeah, switch it. We're gonna leave it off for now. How will all this get plugged? Let me go ahead and plug this sucker in here. Okay, let's see if that power's on. Oh no. Maybe our battery's dead. We're gonna hope that's what the issue is. Okay. I'm using this small jumper box that's gonna run the 5-volt and the ground, but it's looking like I need to go ahead and tie all those in together and just solder them. I didn't really want to have to do that, but I don't have enough room. This is too bulky, so I'm gonna go ahead and do that right now. So I've got all the components that I want to solder here. First, I'm gonna go with the ground. So that's these 3 cables right here. So I'm just gonna go through and strip all of these cables. Not the prettiest soldering job ever, but it'll hold. We've got some heat shrink somewhere around here. Got some heat shrink that we can put onto some of these here. Cut a little bit of it and just put this on the end. That way, none of these contacts can get hit. Let's see. And I'm not proud of what I'm about to do. I don't have a heat gun, so I will be using my soldering iron to heat up the ends here. It takes a little bit of time. Oh, no, there's some. I will just crimp this down while it's still hot. Alrighty, we've got all of our grounds connected. Now we need to do the same with our 5-volt. Alrighty, so all of the 5-volt has also been soldered, and so now we've got the 5-volt and the ground all connected. Now, I hid them a little bit. Nobody's gonna sit here and say, he's the best soldering person ever, but they're soldering and they won't come apart. So it's good. Now move on to the next part. In order to attach the back housing and the front housing, we need to press in some inserts. Alrighty, and we will do that 4 more times. Alright, now they're all done. Now I tried to do a really insane transition there. No, I did. That could have looked terrible, but all 4 of the inserts are in, and now we can attach the rear and the front. It's a big moment of truth here, so we're gonna see if we can fit everything into the enclosure and then screw it all in. So we're gonna see if some of the changes that we made are hopefully make this thing small enough to actually all go together. I guess we'll see. It's gonna be a tight fit. Ooh, it's gonna be close. Golly, that's disgusting. Sorry you had to see that. One of the longest nails on earth. There she is. All right. Okay, moment of truth here. Does this work? Ooh, look at that. Oh my. Color work. Oh. That's it. All we need to do now is hook up the Hall effect sensor and then clamp it to the bike. But right now, I'm really happy with that. This turned out really good. In order to mount the speedometer to the bike, we're going to need the other side of that clamp. So this is going to be that clamp, 3D printed it, and now we're going to heat press some inserts into that. So let's move on to this. So the inserts are going to go into these holes. That way the only bolts you see are on the back of the speedometer and not the front. We're going to be using some M3 inserts. Alrighty, both inserts are in, and now we can attach the other side. Alrighty, now you've got the clamp ready to go. So I actually designed this to be a little bit less than a circle. One of these sides has been cut slightly offset from the center. That way it actually clamps onto the pipe and doesn't just like slide around. Moving on to the Hall effect sensor, now we're going to solder the 3 wires. So in this we have, let me focus here. In this we have a signal wire, a positive 5-volt, and then a negative. So all we're going to be doing is I ordered some really small 26 gauge solid core wires. So we're just gonna solder those all on and then connect it to the Arduino and then put it on the bike. So we're really close to being finished. And so now we're just gonna solder everything up and yeah, let's do it. All right, so now is the moment of truth. We're gonna see if the Hall effect sensor will fit onto the fork. Don't mind my outfit, it's Halloween right now, and I'm Dale from Step Brothers. So we've got a magnet right here on the wheel itself. So we're gonna see if it'll line up. All right, so the clamp's on there, it's pretty solid. It's lined up with the magnet right here. Now we're gonna see if the Hall effect will mount properly and then we can adjust it from there. Got the whole assembly, the Hall effect sensor dangling. Wires will get cleaned up, but for now they're just gonna be loose like this. They're soldered to the Hall effect sensor from earlier. So first I'm gonna attach this to the handlebar so it's not falling around, and then we'll move to the actual sensor. It's on backwards. Doesn't need to be perfect right now. We just want to get it on and see if all the wires fit, and then we can adjust later on. Pretty good. Okay. So now we will see if the Hall effect sensor goes in. After installing the sensor, you can see that the magnet and sensor almost come in contact each revolution, but this will ensure that each time the wheel passes by the sensor, it will actually pick it up. And then I did tie the wires down just for testing right now, and then I will put some loom on these, but that is what it looks like before the test ride. Got everything mounted up. I'm gonna try it out, see what happens. Turns on. Let's see what happens. Woo-hoo-hoo. It's working. Now the speed's definitely off. I'm not going 20 miles an hour right now. We'll have to adjust the radius of the wheel in the code, but it is working. Let's see the other one. All right, so second screen's working. Let's go to the graph. Oh, that looks a little funky. Let's see. Is it updating? Yep, coming in from the left to the right, it is updating. Let's see, let's slow down a little bit, see if it drops. Oh yeah, look at that. Awesome, it's working. Try and speed up here, make the graph go back up. Man. Let's see, is it going up? Yep, 17. 18, 19, yep, look at that. Awesome.
Dude, that is sick.
Is it working?
Yes.
Let's go. So yeah, that's the video. I did it. I made a working bike speedometer. Is it perfect? No, but honestly, that was never really the goal. I just wanted to see if I could take some skills I've learned over the years and combine them into something that actually works. Something that I could use every day. And I think for the most part, I accomplished that. Moving forward, I've got some few things I definitely want to clean up. The momentary switch doesn't even have a nut on the back of it right now, so it's kind of just flopping around as I ride. So that's not a good thing. I'm also going to secure the wiring better. I'm going to add some loom, add some zip ties, and I want to redo the whole enclosure in black and just some overall quality of life improvements. On the software side of things, I'm planning to update the graphing, tweak some font sizes, that kind of thing.
And finally, I want to verify that the speed reading is actually accurate. This is a bike speedometer, so that's pretty important. And I've got this slightly sketchy idea to ride past one of those police radar signs near my school and see if it matches up. I'll admit, it's probably not the smartest method, but it's something, so I can start with that. Anyways, I'm really happy how this turned out, and I'll see you on the next video.